NIOS syllabus. We will be discussing 6 modules. Module number 1 will be for TMA, those who are going to write the public examination. So they will be having only, they should have the basic knowledge about this TMA. Okay. So we will be discussing all the 7 chapters of this TMA chapter. Then in the second module, you will be having the 2 chapters. Here we will be having chapter 1 to 7. Okay. Then in module number 2, you will be having commercial mathematics, in which you will be having 2 chapters, that is chapter number 8 and chapter 9. From here you will have the syllabus for your public examination. From module 3, 4, 5 and 6 you will have your 80 marks of your examination. Okay, 80 marks of syllabus will be from here and 20 marks for the TMA. So that TMA questions you have to solve and upload it on the NIOS website. Okay, then module number 3 is for geometry, and it is the most biggest or the largest module. It will be having chapter number 10 to chapter number 19. Almost 10 to 11 chapters are here. And then in module number 4, we will be discussing about mensuration. This will be chapter number 20 and 21. And then module number 5 will be having trigonometry. That means what is trigonometry, what are the basic applications, that we will be seeing in module number 5. So this will be having 2 chapters, 22 and 23. And last module will be your statistics, which will be having your 3 chapters, 24, 25 and 26. Okay, so these are how. So I will be proceeding it in the way. Firstly, I will be discussing this first module, so 1 to 7 chapter. Then I will discuss this module number 6, that is, as this is a statistics portion. Then this module, and then module number 5, and then module number 4, and lastly I will be discussing geometry module. I hope it is clear to everybody.
Yes, ma'am.
Okay, so now let's proceed. If anything you want to ask regarding this, then please ask me. Otherwise, I will be taking the first chapter of your syllabus. Aarti, Gitika, if you have any issue or if you want then please
there will be 6 modules and TMA is 20 marks and the other is 80 marks. That's it.
This is only for TMA for 20 marks, and rest from module number 2 to 6 you will be having 80 marks paper. This will be your public examination syllabus.
Yeah, okay.
Okay, so the paper you will be writing for the examination, that you will be having from here. Yes, Vedant?
So the 20 marks examination will be online?
No, there will be some questions uploaded on the NIOS website, and then you have to solve and write a file for that, and afterwards, after solving, you have to upload it.
Okay.
Okay.
And the other rest 80 marks will be the offline exam. The exam, not.
Yes. This will be your offline exam, your public examination. Okay, if you will have any question from here, then it will be from the MCQ part for 1 or 2 marks. Otherwise, you will have 80 marks paper from module number 2 to module number 6. Is it clear?
Oh, yes.
Okay. Anything else? Is it clear to everybody? Should I proceed?
Yes, ma'am.
Okay. So in today's class, we are going to start up with the part 1, or you can say your module number 1, which is having 7 chapters, chapter number 1 to chapter number 7. So in today's class, we are going to start up with the chapter number 1, which is number system. As we know that mathematics is all about the numbers only. Is it so or not? Mathematics is only about dealing with the numbers or to analyze anything on the basis of the numbers. This is the reason why we study mathematics. Yes or no?
Yes.
So in this chapter, we are going to see what are the various types of the numbers and how can we use them. If anything you want to ask, then please ask me. Till here, if anything is not clear to anyone, then please ask me. This is all the chapters for the TMA. So you will be having questions in the TMA from these chapters only, from chapter number 1 to chapter number 7. Okay. So what are the various type of the numbers? If anybody, if you have any idea, then please share. What information do you have? What are the types of the number?
Real numbers, rational numbers, irrational numbers, and integers.
Yes. Okay. So if we classify the numbers, basically the numbers are majorly classified as real numbers and the imaginary numbers, or sometimes you can say them as complex number. Okay. So this is the part of your senior secondary level. So till now, whatever the type of the numbers we do study, they all are real numbers. Like as you tell, rational number, integer number, prime number, co-prime number, all the numbers till whatever you have studied, they all are numbers, are what? Real numbers. So how can we say that this number is a real number and this number is not a real number? So the simple definition or the simple way by which you can say that the given number is real number or not, if you can represent any number on the number line. I hope you know this is the number line. This represents the positive sides and this represents the negative side, or whenever we are having any higher value, that will be always on the right hand side, and the smaller number we will be having on the right hand side, just like see 29 and 35. Then you can see the 29 and 35, then 35 is the larger number, so it is on the right side of the 29. Is it clear? And if I talk about 27, that it is on the left side of the given number. So this is the basic classification by which we classify that numbers are of two types, real number or imaginary numbers of the complex. This is not the part of our syllabus, so we will not be discussing about this. Real numbers are those numbers which we can represent on the number line. I hope it is clear.
Yes, ma'am.
Okay. So now real numbers can be further classified majorly into two parts, rational numbers and irrational numbers. So who is going to tell me what are rational numbers? I will start from Gitika. Gitika, what is rational numbers? Kindly do respond me whether you know it or not.
And terminating or non-terminating medium.
Wait a minute. Aarti responds when I ask you, okay? Yes, Gitika.
The number which is in P by Q form is rational number.
Okay.
And
then what is
numbers are 1.4111 means recurring numbers are irrational numbers.
Okay. I hope it is clear to everybody. Rational numbers are those numbers. I hope you all are aware with the word of the decimal expansion. If anybody is not clear about this word, then please ask me. Decimal expansion. Okay. If we are having decimal expansion of anything, is either terminating or non-terminating but repeating. Non-terminating but repeating. Then such numbers are known as what? Rational numbers. And whereas we are not having non-terminating decimal expansion, okay, and non-repeating also, then such numbers are known as what? Irrational numbers. Is it clear? The example of the rational number are 1/3, 2/7, any number, okay. And if I talk about irrational number, then you can say 1.4132, 1.732, so on, any number, okay, or 3.14732. These all are the examples of what? Irrational number. I hope it is clear. Generally, we do find any number with this square symbol and having any value which is a non-perfect square of, okay, non-perfect square, then all such examples are of irrational number, root A. Is it clear? If in general form, if I
Yes,
represent
ma'am.
irrational number, then I will be writing as root A. Is it clear to everybody? Aarti, I hope it is clear to you.
Ma'am, I have problem in a root A. Please, could you explain it again?
Root A is the general representation. Just root 2 is a rational number. So in the general form, to represent this, I have just mentioned it. It is a way to represent this in the general form, irrational number. Okay.
ma'am.
Any number can be here at the place of A, but it should not be a perfect number. Just if I write root 25, then it is not an irrational number, because we know that 25 is a perfect square of 5. I hope it is clear, Aarti.
Yes, ma'am, it's clear.
So root A, at the place of A, we can have 21, 31, any number. Okay. So in general form, in general representation, I have represented it by root A. Is it
Okay.
clear?
Yes, ma'am.
Vedant, do you want to ask something?
Yes, ma'am. I
Please.
did not understand this part.
Which part?
The root part you are explaining.
As we are discussing in the class, that how can we classify that the given number is rational number or the irrational number, then I discussed with you that by the help of the decimal expansion, we can say that the given number is rational number or irrational number. If we are having any decimal expansion which is terminating or non-terminating, but having the digits are repeating, then such numbers are known as rational number. Whereas the numbers whose decimal expansion is neither repeating and non-terminating, then such numbers are known as what? Irrational number. So for example, for that I had just explained you that generally we can say that irrational numbers can be represented by the form of the root A, where A will not be a perfect square number. Is it clear, Vedant?
Yes, ma'am.
As I have taken two examples, that root 2 is not a perfect square, so it is going to, the decimal expansion of the root 2 is 1.414 and so on, so it is neither repeating and non terminating. So it is an example of irrational number. Or if somewhere if I find root A is as 25, then it is not a irrational number, it is a rational number, because 25 is a perfect square number. I hope the difference between rational and the irrational number is clear to everybody in the class.
Yes, ma'am.
Yes, ma'am.
Vedant, is it clear to you?
Yes, ma'am.
Okay. So now our chapter will be starting from here itself, that what is rational number and what are its property. Okay. So now I hope you all are clear with what is rational number. Generally in the junior classes, we say that the any number which can be represented in the form of q, p by q, and where q cannot be 0, then such numbers are what? Rational numbers. But now, as if we are in some higher standard, so we will be saying any number is a rational number whose decimal expansion is either terminating or non-terminating but repeating. Non-terminating but repeating digits or the group of digits. Okay, then such numbers are known as what? Rational number. For example, you can write as 1/5, 1/3, and so on. Is it clear? I will be showing their decimal expansion, so you will understand it more clearly. But till now, please note it down this, then I will be proceeding further. And if any one of you have any doubt, then please ask me. If you all have noted it, then please tell me.
Noted.
Vedant and Aarti.
Yes, ma'am, noted.
Vedant, I hope you have also noted it.
Yes, ma'am.
Okay, now let's see what is mean by the decimal expansion. So one first example I have taken is 1/5. So we will be dividing the numerator part with the help of the denominator. So we know that 1 is the smaller, so we cannot. So we will be putting this decimal sign and taking 10 or taking 0. So now it will be, so we will be getting a 0.2. So this is the decimal expansion. So you can see that the on dividing it, our divide is terminating. So it is a what type of number? Rational number. I hope it is clear.
Yes.
Okay. The another example I have taken is 1/3. So you can see this also. Again, this 1 is smaller. Then I will be putting this decimal number, taking 10. Now 3 3s are 9. Now again 1. Then again 0. Then 3 3s are 9. 9. Okay. And so on. That I will keep on dividing and my number 3 will be repeating. Then such a number is known as decimal rational number. But with what type? With repeating time, we do represent this number in the way 0.3 bar. The bar is representing that this particular digit or the group of the digits, here only one digit is repeating. So I just put the bar only on the one digit. If 2 or more digits will be repeating, then I will be putting this bar on all those digits. That means this 3 is going to become the infinite time. So I hope both the things are clear to everybody.
Yes, ma'am.
Yes, ma'am.
Okay, and one more method is there in order to identify whether the given number is a rational number or not by seeing its denominator. If you can represent the denominator of any number if in this way, okay, then such a number is known as what? Then such a number will be rational number. Of what type? Terminating type. And if we cannot represent any number with in this form, then that number will be non-terminating time. Is it clear? As you can see, 1/5. So we can represent this denominator as 2 raised to power 0 and 5 raised to power 1. So you are getting here decimal expansion as terminating type. Is it clear? And here you can see 1/3. Here the denominator part, we cannot define it in the form of what? 2 and power 5, 2 base and 5 base. Then this is giving us non-terminating decimal expansion. Is it clear to everybody?
Ma'am, 2 and 5 are constant.
Sorry.
Ma'am, 2 and 5 are constant.
Yes, this is the fixed condition that if a number is a terminating type, then it will be always be represented in the form of 2 raised to power m and 5 raised to power n. Is it okay?
Yes.
This is the condition. So without doing its division, by seeing its denominator part also, we can conclude that whether the given number is going to give us a terminating type of decimal expansion or non-terminating type of decimal expansion. I hope all the things are clear, whatever we have discussed so far in the class. Just now we have just discussed that maths is all about dealing about the numbers. So we do have started with the classification of the numbers. So broadly we do classify the numbers as real and the imaginary numbers. Imaginary numbers we shall not be discussing because it is not the part of our syllabus. So we are going to only deal with the real numbers. So real numbers are those numbers, the numbers which we can represent on the number line. Then all such numbers are known as what? Real numbers. And real numbers are further broadly classified into two types. First is rational number and other is irrational numbers. All the decimal numbers or all the numbers whose decimal expansion is either terminating or non-terminating but they are repeating, then such numbers are known as what? Rational numbers. and the numbers whose decimal expansion is neither repeating and non-terminating, then all such numbers are known as what? Irrational numbers. Generally, we do see irrational numbers as in the form of under root a, where a will not be a perfect square number. A will not be a perfect square number. Any other number we can have, just as 21, 37, root 5, root 7, root 11. So all these are examples of irrational number. Is it clear?
Yes, ma'am.
Ma'am,
Till-
I
हाँ.
have problem in like 2m multiply 5 and
हाँ.
they're completely out of my mind.
You don't have to worry. It's just a or method. Just I want my students to be little more advanced. So instead of doing its complete division by seeing its denominator part, if you can break the denominator part, I hope you do have idea of the prime factorization, Aarti.
Yes, ma'am.
So if you are having the prime factorization of any the denominator part of any number, and you will be getting 2 power m or 5 power n, then this particular type of the decimal expansion will be of terminating type. That means without actually dividing this type in the way, you can conclude it by seeing its denominator part, whether you will be having a terminating type of decimal expansion or the non-terminating type of the decimal expansion. I hope the application of the formula is clear to you, Aarti, now.
Yes, ma'am.
You don't have to do, just as c 1 upon 8. Okay, as this is a number. So instead of doing its decimal expansion by seeing its denominator, I know the prime factorization of this 8 will give me as what? 2 raised to power 3.
Yes.
So I am getting as 2 power m, as this was the condition. So I will be getting its decimal expansion of what type? Terminating type. I hope it is clear now.
Yes, ma'am.
Now you can also check it by here also, that this is 0, then I will be putting this decimal and getting 1 0. So 8 ones are 8. Now I will be having 2, then 0, then it will be go 2 times, then I will be get 6, and then 4, then 5. So you can see the decimal expansion is terminating. So without doing its actual this decimal expansion, by seeing the denominator part, I can also conclude that whether the rational number or whether the given number is going to give me a terminating type or non-terminating type. I hope the application of this formula is now clear to everybody.
Yes, ma'am.
Okay, just it is a small method that if you will have in 1 marks or in MCQ type question, so instead of investing your time in solving the complete decimal expansion, by seeing its denominator, you can conclude that whether you will be having a terminating type or non-terminating. I hope it is clear to everybody.
Yes.
Okay, so now in this chapter we will be focusing on what? On rational numbers. So now we do have now sufficient knowledge that how can we say that the given number is going to be the rational numbers. Okay, so rational numbers are of 2 types: positive rational numbers and negative rational numbers. All the numbers which are having positive sign, they are positive rational numbers, or the rational numbers which will be having the sign with the negative sign, they will be negative rational numbers, just as -6/7, -2/3. These are all are examples of negative rational numbers. 2/7, 2/5, these all are examples of the positive rational numbers. I hope it is clear.
Yes, ma'am.
Okay, so till now, whatever numbers you have studied or whatever numbers you know, prime number, co-prime number, even number, odd number, twin prime number, or any type of number, composite number, they all are what? They all are rational numbers. Okay.
Yes, ma'am.
Okay.
Integer number is also a rational number. I hope it is clear.
Yes.
Ma'am.
Any doubt till here? If any one of you have, then please ask me. If not, then should I proceed further?
Yes, ma'am.
Okay.
Yes, ma'am.
Okay. So now we will be going to see the how to use the number line in order to in order to solve the, basic operations, addition or subtraction from the number line. So let's take a question. So first of all, let's represent a rational number on the number line. Representation of rational number on number line. Okay, so let's take first part as that we have to represent as 2 upon 5 on the rational number. So how we are going to represent? We will be drawing this as 1, then 0, then this will be positive and this will be negative side. So as you can see, this is a positive rational number. So we will be having this on the right side, and all now what I will be doing, as you can see, this is the proper form. I hope you are clear with the proper, improper and the mixed form. When the numerator is small and denominator is greater, then this form is known as proper form. If we will say that the denominator is numerator is greater than, if I say denominator is greater than, denominator is greater than, suppose 17 upon 5. So here numerator is what? Greater, and denominator is what? Smaller. Then this form is known as what? Improper form. Okay, and last form is a whole b upon c is the form of the mixed form. Okay, so if we are having any proper form, then it will be always be located or represented between 0 and 1. I hope it is clear.
Yes, ma'am.
So between 0 and 1, as this is on positive rational number, so this will be between 0 and 1 on the positive side. So I will be drawing now this denominator part on this in between 0 and 1. So 1, 2, 3, 4, and this is 5. Okay, so now how much I have to locate? I have to locate as 2 upon 5. So I will be going as 1, 2. So this will be this position will be showing as 2 upon 5. I hope it is clear.
Okay, it means
Yes.
there is also numbers.
Yes,
before
there are infinite number between two rational numbers.
Okay.
Infinite numbers. We can also further divide this. There are infinite number between two rational numbers. As we write 2 or 3, there are infinite numbers in between 2 and 3. I hope it is clear, Aarti.
Yes, ma'am.
Okay. Till here, is it clear to everybody? Vedant and Gitika, I hope you both are also getting.
Yes.
Vedant, are you getting?
Yes, ma'am.
Okay. So now this is the way by which we will be representing the proper. But how if we want to represent this improper rational number on the number line? Then we will be converting it into the mixed form. How we will be converting? We will be dividing the numerator by the denominator. So we know we will be dividing and converting it into the mixed form. So 5 3s are 15, and we will be left with 2. So the mixed form for the 17 upon 5 will be 3 whole 2 upon 5. I hope it is clear.
Yes, ma'am.
Now what I will be doing, I will be again creating a number line. Okay, this is 0, this is -1, -2. Now what? As if the question was of proper form, then I will be always dividing the 0 and 1 between the into the denominator sections. But when I will be having a proper improper form or the mixed form, then what I will be seeing this mixed part. As this is 3, so I will be dividing this number or further fractionating 3 and 5, 3 and 4. I hope it is clear. As it is 3, so I am splitting between 3 and 4. If it will be 5 whole, suppose 6 upon 7, then I will be splitting between 5 and 6. Is it clear?
Okay, ma'am.
Okay.
No, ma'am, I did not get this.
Just a minute, let me finish it, then I will be explaining it again. So now I will be splitting this 3 and 4 between how many sections? Between 5 sections. So 1, 2, 3, 4, and this is 5. Okay. So now what I have to do? I have to locate as 3 whole 2 upon 5. So this is 3 whole and 2 upon 5. So this will be my position 17 upon 5, or you can say 3 whole 2 upon 5. Okay. Ha, Vedant, from where you didn't get
The whole number part, ma'am.
this? Okay. as we were splitting here, as it was the number, proper number, we were splitting between 0 and 1. Is this clear to you, Vedant?
Yes, ma'am.
Okay, so now if we will be having an improper number, then we will be converting this improper number into the mixed form. I hope the conversion into the mixed form is clear to you.
No, ma'am.
Okay, this part is not clear to you.
Yeah, yes. It's not,
Okay.
it's not.
Okay, let's take one more example. 2 upon 3. So let's say 2 upon 4. As you can say that it is again an improper form, Vedant. You can say that numerator is greater than what? Denominator. So we will be saying that this is an improper form, Vedant.
Yes, ma'am.
Now I will be dividing this numerator with the help of the denominator. So I hope you are aware how to divide.
Yes, ma'am.
So we will be dividing it for 5. So we will be getting as 1. Okay. So now 1 is smaller than 4. So we will not be going for the decimal expansion. We will be leaving here only. So now I can write as 21 upon 4 or 5 whole 1 upon 4. Is it clear, Vedant?
Oh, yes, ma'am.
This is QRD form. Q for question, R for reminder, and D for divisor. Is it clear?
Yes, ma'am.
So I have converted this into the form of QRD form. If you are not clear, then please note it down this. QRD form, Q stands for question, R stands for reminder, and D stands for divisor. So as I will be having its QRD form, then whatever number will be the whole number, this part, or okay, then the number after this, as it is 5, then after 5, which number will come? 6. So I will be splitting between 5 and 6. As here you can see that I was having 3 whole 2 upon 5. So I have split it between 3 and 4. Vedant.
Yes, ma'am.
Okay. So now I will be splitting this between 5 and 6. Okay. So again 0, 1, -1, -2, and so on, -3. Here +1, +2, +3, +4, +5, and 6. How many parts I will be dividing it into the 4 parts. So 1, 2, 3, and this is 4. So here I will be having a 6. So we have as 5 whole 1 upon 4. So we will be till 5, and then from here is 1 upon 4. So this will be part. So this is going to represent as 5 whole 1 upon 4, or you can say that 21 upon 4. Is it clear, Vedant, now?
Yes, ma'am.
Should I explain it once again, or is it okay?
It's clear, ma'am.
Okay, so in the way you have to represent the any rational number on the number line. If anything is not clear till here, then please ask me. Gitika, Aarti, okay?
Ma'am, I think everything is clear to me, but the what you have done on page number 10, I am still confused here. I don't know why.
Here,
Yes.
if you are confusing, then skip it, as it was only the simplest way, that by this formula, instead of actually doing its decimal expansion, without doing its actual division, you can, by seeing its a denominator part, you can conclude that whether the given number is going to give us a terminating type of the decimal expansion or the non-terminating type of the decimal expansion. As this formula, the application of this formula is only this only, that instead of doing the actual division, by this actual division also you can conclude that you are having a terminating type or the non-terminating type. But in order to save the time, so instead of doing its division, by seeing its denominator part, if we will be having the denominator part as in the form of 2 raised to power m or 5 raised to power n, then we can say that it will give us a terminating type of the decimal expansion, or if it is not represented in this form, then we will be saying that it will give us a non-terminating type. If you are now clear, okay, otherwise no problem. You have another method to state that the given rational number is a terminating type or non-terminating type by doing its actual division. I hope, Aarti, now is it
Yes,
clear?
ma'am. Yeah.
I have discussed two ways
Yes.
that
ma'am.
that how you can say that the given rational number is going to give you a terminating type or the non-terminating type of the decimal expansion. One method is this conventional method by which we will be dividing and then we will be concluding it. And other method I have discussed this as this is just an optional method, an application that instead of doing its division, by seeing its denominator part, you can conclude that we will be having a terminating type or the non-terminating type. If you are getting confused, so no need to worry. These two methods are for the same purpose. So if you are not clear with this, skip this, use
Yeah.
this.
Now it's clear. Thank you.
Anything else? Vedant and Gitika, I hope it is clear to you.
Yes, ma'am.
Yes, ma'am.
So in today's class, we have just taken the introduction of this number system. We will be discussing the various operations on the rational numbers, then irrational numbers. Okay, we will be also having the questions in which we have to find out the rational numbers between the two rational numbers. We will be discussing to find out the irrational number between two rational numbers. Many more things to come in the chapter. I hope whatever I have discussed with you all is clear and you are getting everything.
Yes, ma'am.
Yes, ma'am.
Okay. You are finding the class is useful to you?
Yes, ma'am.
Okay.
Ma'am, I can watch this class later, na? Because it is being recording.
Yes,
Yes. Mhm.
the class is being recorded. If you are unable to take class any day due to some reason, then you can see its recording. Okay.